Hi, welcome to ISE503, and this lecture is Relational Databases Part 3, and the lecture slides are taken from our textbook, which is Principles of Database Management. Okay, so what we have to learn in this lecture, we will go over the mapping of the conceptual ER model to the relational model. So in this whole lecture, we will go over this concept of mapping entity types, then the mapping of the relationship types, mapping of the multi-valued attribute types, mapping of weak entity types, and finally I'll put everything together, whatever we discussed in this chapter, relational databases. So here you're looking at on the ER diagram. I would say rather two entity types you're looking at. I will mark those as 1 and 2, and yeah, let me divide this into two parts so that we remain focused on one entity type. So the one that I have marked as and the entity type that I have marked as 1 is for employee entity type. And for employee entity type, as you can see, we have the attribute types like social security number, which is our primary key. Then we have the entity type address, which we will consider as atomic. And then we have the attribute type ename for employee entity type, which is composite. And here it should be broken down into two parts, which is first name and the last name. Now, whenever we have an entity type like employee, now question arises, how are we going to map it to the corresponding relational database? So for this entity type employee, we will have to create a relation with the name employee. How will that be done? Here we go. Right, so you're looking at this employee relation that we will create for the entity type 1. So you'd say employee, and then we will be using parentheses, and between the parentheses we will provide all the attribute types from the ER diagram. Okay, so you would see that we have SSN here, then followed by address. Then in place of having ename like this, for ename we would rather have two attributes like first name and last name, and that's how we will map an entity type employee to the corresponding relation, that is employee over here. Okay, you should be careful about this mapping. If somebody is asking you to provide the relational database corresponding to an entity type, then that's how you do. Here you're rather creating a relation. I should not say the database, because just one relation employee would correspond to the entity type employee. Similarly, we can do the same thing for the second entity type, which is project, right? So for project entity type, again, we'll have to create a relation. And how do we do that? Let's have a look at that here, right? So in order to provide the mapping, I would use 1 here, and let me put 2 over here, because now in 2, what do we have? We have the relation named project, which would correspond to the entity type project over here. Okay, so you would write project, you'll make use of the parenthesis, opening and closing, and between the parentheses you'll put all the attribute types from the corresponding entity type. So therefore, you will have PNR for project number, which is our primary key. P name, that is the attribute type for, or the attribute you may call for the attribute type P name, and P duration, that should be the project duration. Okay, so the mapping of entity types, I would say, was straightforward, right? Very simple compared to what you're about to see. Okay, just create one relation for each entity type, and in that relation you will have to provide the mapping of the attribute types, right? So that's what you must have understood in this the very second slide, I would say, in this lecture. Now, comparatively difficult thing is the mapping of relationship types, and we have already seen in the ER diagram when we were learning. we've identified different kind of relationships, right? So when we have to learn about mapping of relationship types to relation, and then we need to consider all the kind of relationships possible. So we would look at the mapping of binary one-to-one relationship type. Then we will look at the mapping of binary one-to-n relationship type. Then mapping of the binary m to n relationship type, followed by mapping of unary relationship types, and then we will look at the mapping of n-array relationship types, right? So here all these bullets that you have, they correspond to different kind of relationships which are determined on the basis of um, when we are saying binary unary, then that relates with binary unary and n-ary, that relates with the degree of relationship, whereas one to one to n, m to n, these are all the cardinality of relationships. Okay, so let's look into the first thing first, which is about mapping of a binary relation, which is one-to-one type. Okay, so well, since it is binary, therefore there will be two relations involved, or you can say, there are two entity types involved. So if there are two entity types involved, then for each entity type, we'll have to create one relation. That's the reason we say we create two relations, one for each entity type participating in this relationship type, which is one-to-one. Then there is a relationship, right? And relationship involves the association, which you can call as connection as well. Now the connection can be made by including foreign key. Now the foreign key is going to help us in connecting the relations that would correspond to the two entity type. So the connection can be made by including a foreign key in one of the relations, and that foreign key will refer to the primary key of the other. Okay, so yeah, that is going to be the approach. We will use a foreign key, and we can well, we can put in any one of the relations. You will see that discussion, but ultimately we'll have to decide in favor of the putting the foreign key in a relation that is going to reflect most of the cardinalities. That's what we will discuss soon. But for the time being, let's make sure that we understand these basics. What are these? One more time. For since the relationship that we are trying to map is binary, we would need to create two relations, one for each entity type that are participating in this relationship, and then the connection will be established by using the foreign key, and foreign key we can put in one of these two relations, and the foreign key has to refer to the primary key of the other relation. Now this is an important concept. Okay, so please pay attention to that. What does it say? In case of existence dependency, we will put the foreign key in the existent dependent relation, and we'll declare that as not null, right? So that's very important, and I would request you to keep this concept, make sure that you understand it, and with the help of an example that you will see very soon, this will be a lot clearer. Okay, so let me help you out with this concept of existence dependency, if you don't remember that now, because we did learn about it. If you have two entity types, then one of the entity type would be called existence dependent if that entity cannot exist without being associated with the other entity type, right? So the entity type that cannot exist by itself is called the existence dependent. And for this dependent entity type, there should be another entity type on which this existent dependent entity type is dependent. All right, so if we have that kind of scenario, then yeah, in that case we should put the foreign key in the entity type which is existent dependent, or the relation which is existent dependent, and in that case we will have to make the foreign key not null, otherwise this existent dependence thing will not be able to will not be cannot be will not be able to be implemented. Now, the attributes, the relationship types, they also have attributes. Now, the attribute types of one-to-one relationship type can then be added to the relation that has the foreign key. Okay, so if you want to enforce the previous bullet where the one of the entity type is existence dependent, then in that case the attribute type should of the relationship should go to the relation that corresponds to the existent dependent entity type. Okay, because the foreign key would be needs to be put in the relation that corresponds to the existent dependent entity type. I know it's getting a little intense. Don't worry. With the help of the example, this will be a lot simpler. So here we go. Now we have an ER diagram to explain the relationship that we are discussing right now. It's binary one-to-one relationship type, and the entity types involved are employee and the department. Okay, so here it's one to one because look at it, the cardinality, right? Our assumption is, or our business rule is such that we are allowing it to be one to one. Now, how do we determine that it is one to one? You need to pay attention to the maximum cardinality, right? So the maximum cardinality at each end of this relationship will determine whether it is one to one or one to many, right? So here it is one to one because the department, if you want to understand what is the meaning of this relationship, then yeah, we have entity type employee with the attribute types SSN, e-name, and address. SSN is our primary key. Then for department, we have attribute types DNR for department number, DNAME for department name, and DLocation for department's address or department's location. Now, in this one-to-one relationship that we have, which is binary because there are two entity types, the relationship is called managers. Now, one employee, right? Let's try to understand this relationship from employee side. Then it says that one instance of the employee entity type can manage zero department or one department at max, right? That's how we read these cardinalities. So from employee side, an employee can manage zero department or maximum one department. Okay, and now if you want to understand this relationship in the other direction from department to employee, then that means one to one. That simply means that a department will have minimum of one employee as a manager and maximum of one employee as a manager. That simply means that a department would be managed by one and only one employee. All right, so that is the relationship that we are looking at. And yeah, it is one to one because for the cardinality of the relationship, we pay attention, we consider the maximum cardinality, and here it is one and one on both the sides. Okay, and this is what we have to map to a relation, a relational data model, I should say. What you're looking at is an model, which is a conceptual data model. We have to map it to the relational data model, which is logical data model. Okay, now let me explain to you this concept that the department here is existent dependent on employee. Why? Well, for department we need one and only one employee as a manager. Therefore, if there's no manager, then yeah, the department will not exist, right? So in this diagram that you're looking at, the department entity type is existent dependent on employee. Okay, this is important. Please make sure that you followed it. And as I said, for the cardinalities, if you did not remember anything that we discussed in the previous chapters, then yeah, probably you would have to go there, go over these concepts, and then come back again, because in order to understand these things, you should have very good understanding of the cardinalities and the degree of relationship types. Okay, so how do we implement this relationship in the relational data model? Well, there are two entity types involved, employee and department. So first we need to create the relations for employee entity type, and one relation for employee entity type and another one for department entity type. Okay, so I would request you to pay attention to this part that I marked as A. Why? Because here we have two relations defined. Relation number one is employee with the employee's attribute types here as social security number SSN as the primary key, e name or employee name, and the address for employee. For the time being, I'll say please ignore the other attribute, which is DNR or department number. We'll look into that later. And here what we have, the other relationship, which is the other relation rather, department is for the entity type department. And here the attributes are DNR for department number, which is the primary key, DName is for department name, and D location is for the location of the department or the address, in other words. Now what has been done here? Now question arises, why did we add this attribute, which is DNR, to employee? Okay, the reason is that we have to provide the mapping of the diagram to the relational data model. Okay, and this in fact is going to serve as a foreign key, and we did learn about these things, right? So where? Right here. Okay, right here I did discuss these things, right? Like how are we going to map a binary one-to-one relationship type? First, we will create two relations, each relation corresponding to one of the entity type, and then we will use a foreign key and we'll put foreign key in one of the relation. So what are we doing here? We are exploring all the possibilities. There are two possibilities, right? We could either put the foreign key here in employee, or we can put that in the department. So we are considering the first option here, where we are putting the foreign key, which is DNR, into the employee. Okay, and the DNR is coming from the primary key DNR of the department, right? So perfect mapping of the foreign key. Now, with this mapping or the implementation of a relational data model for the diagram that you saw in the previous slide, we need to check that whether it was a smart move or not, right? To validate that, I will take you to the part B of this slide. And in the part B, what do we have? In the part B, we have the tuples, right? Corresponding to these two relations. So for employee, let's see what we have here. Here we have 1, 2, 3, 4, 5 tuples of 5 record. The first one is for John Smith with the SSN 511, and John Smith has some address in New York, and John Smith is managing the department number 1. Okay, now which is the department number 1? For that we'll have to see the department relation with the tuples, right? So department has the attribute department number, D name, and location. So 001 corresponds to marketing, which is on the 3rd floor. 2 is for call center, which is on 2nd floor. 3 is for finance, which is basement, and 4 is for ICT, which is in the 1st floor, right? So the very first tuple that corresponds to John Smith, it has the department number as 001, which means that John Smith is managing the department which is marketing. That's a perfect. We are in a way successful in mapping the relationship in this way. Okay, similarly Paul Barker, well, Paul Barker has the DNR as 3, which means that Paul Barker is managing finance. How about Emma Lucas? Emma Lucas has null, which means that Emma is not managing any department. That's fine, right? Our diagram, let me take you back here, well, allows this thing, right? It says that an employee can manage zero department, and at max it can manage one department, right? An employee cannot manage more than one department. That's what we need in accordance with our diagram. Okay, so this zero thing is satisfied because we have a tuple like Emma Lucas, and she has the department number foreign key as null, meaning that she's not managing any department. Then we have Michael Johnson, similarly a foreign key being null, meaning that Michael is not managing any department, whereas Sarah Adams, she's managing what? The department number 1, which is marketing, right? So yeah, one of the cardinality, which is 0 over here, this thing is satisfied, right? Because Emma Lucas and one more employee, they are not they are not managing any department. Good. And then the question arises, like for a department, how many managers we can have, right? So the question is, can a department have more than one manager? Right? That's a question, because our cardinality says that the department should have one and only one employee as the manager. Okay, so in this form, in this implementation that we have, can we have more than one department managed by an employee? The answer is no, right? Why? Because here you cannot have multiple entries, right? Multiple entries are not allowed, because this is in first normal form, and first normal form says that in a cell you cannot have multiple entries, multiple values, right? So this cardinality is satisfied by this implementation. One and only one is satisfied, right? So 1, 2 and 3, three cardinalities are satisfied. Now the fourth cardinality, I think 1, 2. Okay, there's one more cardinality that we need to check. The other cardinality is about the fact that how many managers do we have for one department, right? Wait a second. A department should be managed by one and only one. This is something we have to check, right? So probably this is not satisfied. My bad, I think I explained something incorrect previously. Please ignore that. The issue is that a department should be managed by one and only one employee. But here, if you look at it, right, then John Smith as well as Sarah Adams, what are they doing? They are supervising the same department, which is marketing, right? So in this implementation, these two cardinalities are not satisfied, right? One and only one. So these two cardinalities are not satisfied. The cardinalities which we have on the employee side are not satisfied by this implementation. Whereas, are these cardinalities satisfied? Let's consider that one more time, because I made a mistake probably a couple of minutes back, so I'm going over this thing again. So an employee can supervise 0 department. Yes, we have the case like nulls over here, right? Null. Yeah, so Emma Lucas, she has the null. She doesn't supervise any department. Now the other thing is, can an employee supervise more than one department, right? So that's something we have to see, because ESI diagram says that an employee should supervise maximum of one department. So in this implementation, yeah, I think I explained the same thing. Can we have more department entries over here, right? The answer is no. John Smith is only supervising one department, which is fine, marketing. But marketing is being supervised by multiple employees like Sarah Adams and John Smith, right? So to summarize, this implementation is not looking too good, because out of the two force cardinalities that you see here, 1, 2, 3 and 4, only 2 are satisfied, right? So what we will do, we will see, like, should we try the other way around? What's the other way around? The other way around would be to have the foreign key in the department table in place of having the foreign key in the employee table, right? So let's explore the other option, and here's the second option. Okay, so here what we did, the social security number of the manager is now kept in the department relation. Okay, and employee relation is just the normal employee thing, with employee having social security number, SSN, employee name and the address. And for department, you have the department number, department name and the location. These are the actual attributes attribute types of the department entity type, whereas this SSN thing that you have here is coming as the foreign key, the foreign key of the manager of the department, right? So the social security number in the department would correspond to the social security number of the manager of the department. Okay, now with this kind of mapping we will evaluate like how many cardinalities is this implementation of mapping satisfying. Okay, so as we did in the previous slide, we will try something similar. Okay, so here we have the some tuples, and there are three tuples that you see in the top, and these three tuples correspond to the employee relation, social security number, the name, and the address. John Smith, Paula Barker, and Emma Lucas. These are the three employees that we have. And then for departments, we have the department number, the department name, the location, and the social security number of the manager. Okay, now one thing that we have to do in this implementation is that since the department is existence dependent on employee, therefore SSN that we have here, foreign key, should be not null. All right, so in this mapping, well, in the previous one, if you remember, we did allow the here the department number, which was the foreign key for employee in the previous mapping, had null values, right? But when you put the social security number as the foreign key in the department, we can't have this null because department is existence dependent. Okay, good. So for that reason, every department will have one and one what manager. Okay, so because of this, wait a second, right, I'll have to use eraser to erase what all I have written here in explaining the previous simple mapping. Good. So the point is that in this second mapping, where we are putting the foreign key in the relation department and making that not null, this one and only one, where is my pen? These two cardinalities are supported. One, well, it is not null. Therefore, for a department, we must have at least one employee to work as a manager, right? I'm saying at least one. Now, question is, can we have more than one? So let me explain to you why we can or we cannot, right? So for department, let's see, marketing, right? The manager is 511. Okay, but the question arises, like for this marketing, can I add one more manager? The answer is no. Why? Because this relation is in first normal form, and the first normal form does not allow multiple values there, right? So in this way, if you make it not null and do it this way, then yeah, the maximum one is also satisfied. So these two constraints are satisfied. We have to now check about these things, right? Like employee can manage 0 department, and employee should be able to manage only 1 department, not more than that. So we have to check these two constraints now. Are these two constraints satisfied by the second mapping, second kind of mapping, where we have the foreign key in the departments relation? So yeah, we would use these tuples to convince ourselves. So, one thing that you should be able to see here is that in the first and second tuple, the SSN number is same for the manager, right? So 511 corresponds to John Smith. So in this implementation, John Smith, as you can see, is managing 2 departments, right? Which is against what we need, right? We want an employee to manage only 1 department. All right, but here that's not the case, right? An employee is in fact managing more than 1 department. Okay, so one of the constraint is not satisfied. How about the 0 means the employee should not be we may have an employee who may not manage any department. Do we have any such scenario here? So for that, let's see this we'll have to look at the the manager's SSN. So we have 511 that corresponds to John Smith, then 289 is for Paul Barker, but we don't have 356, right? So yeah, we can have an employee like Emma Lucas that is not managing any department, right? So here 3 out of 4 cardinalities are satisfied. So we should prefer the second mapping of the ER diagram compared to the first one, because here we are able to enforce three cardinalities compared to the previous one where we were able to only support 2 cardinalities. But one thing you should notice is that even with this, we are not able to force the requirement that an employee should be able to manage only one department. So even the relational model, they may have some information loss, and in that case we'll have to keep record of the information that we are losing, so that this information can be enforced at the later stage, right? Probably at the stage of the application development. Guys, these things are very important, right? Understanding the difference between these two mappings, right, where we have a foreign key. We in the first version we had the foreign key in employee, but here we have the foreign key in the department relation. Now let's move on to the second cardinality type, which is binary one-to-n relationship type. Now binary one-to-n relationship type can be mapped by including a foreign key in the relation that corresponds to the in a relation corresponding to the participating entity type at the end side of the relationship type, right? So this is simpler compared to one to one, because in one to one we had one on both the sides, right? Both the entity types, they had one at their end. But in case of one to n relationship type, you'll have two entities entity type. It's binary, so two entity type. One of the entity type will correspond to one side, the other entity type will correspond to n side, right? So the rule here is that we will be putting the foreign key in the relation that corresponds to the participating entity type at the n side of the relationship, right? We'll have an example that will help us out in understanding this mapping. Now the foreign key refers to the primary key of the relation corresponding to the entity type at the one side of the relationship type, right? Simple enough. That's the rule of foreign key. It has to refer to the primary key of a different relation. Not always different, but here it is going to be different. Now it all depends on the kind of business rule that we have. So depending upon the minimum cardinality, the foreign key can be declared as not null or null allowed. So if the minimum cardinality is 1, then yeah, we'll have to make it not null. Otherwise, if the minimal cardinality is going to be 0, then yeah, null could be allowed. All right. So the foreign key can be declared as not null or null allowed depending on the minimum cardinality. Now the attribute type, this is interesting. The attribute type of one to n relationship type can be added to the relation corresponding to the participating entity type. So it's not very clear here, but it goes to the n side of the relationship. Okay, whatever attribute you have for the relationship type goes to the relation that has the foreign key. Okay, now let's use an example. So in this example, you're looking at the two entity types, employee and department. Excuse me. And for employee entity type, we have the attribute types, attribute type social security number, e-name and address. For department, we have D number, D name, and LND location. And here the name of the relationship has changed now. Earlier also we were probably using the same two entity type, but the relationship there was managers. An employee manages a department, but here it is works in. Okay, so an employee works in a department. Okay, and department has employees. Now this relationship that you have has the cardinality 1 to n, right? For 1 to n, we will look at the maximum cardinality, n at employee side and 1 as the department side, right? So that's what I was referring to. N side is the department, the n side is employee side. N is close to the employee because one department will have multiple employees, right? An employee will work in one and only one department, right? That's the rule. So yeah, this is 1 to n relationship type. And the minimum cardinality here is 1 and 1 on both the sides. Okay. And this relationship has the attribute type, which is starting date. If an employee is working in a department, then yeah, we would have a date from which the employee started working in that department. Good. So the first thing that we need to do is to have the relation corresponding to each entity type. So let's look at the employee. For employee relation, you have the social security number, SSN, which is the primary key, then the employee name, e-name, the address, the starting date, right, and DNR, right? What is DNR? This is the foreign key. So this, what you have over here is in accordance with the rules that we learned in the previous slide, which said that the foreign key goes to the relation that corresponds to the end side of the relationship entity type. So end side relationship entity type is employee here. Therefore, the foreign key DNR, which is department number, has been put in the employee relation. Good. And this attribute starting date has been also put inside the employee relationship only. Employee relation only, because employee got the foreign key. How about the department? Well, the department relation would be simple department relation, like department with DNR its primary key, D name and D location. Here we did not put any um, additional attribute. Okay. Now, yeah, what we can do here, this DNR should be put as not null. Why? Because for every employee, there should be one department assigned to it, right? So what we would do, probably we would look at some tuples, and here we have it. Okay, and we'll from these tuples we'll try to see like what cardinalities are being supported and what not. Good. So for employee, we have these tuples, John Smith, Paul Barker, Emma Lucas, and they all have some department, right? Like John Smith is working in marketing because 001 corresponds to the primary key DNR over here, right? So this is our foreign key. Okay, and these values you're getting from the primary key, which is the DNR of department. So yeah, it is possible for one department like marketing, if you look at, to have more than one employee, right? Which is John Smith and Paul Barker. You can easily see that. And Emma Lucas, she works in the department too, which is call center, right? Fine. So for these three employees, we have their departments, right? Now let's see what does the ER diagram say. Well, the ER diagram says that an employee would, belong to one and only one department. So, is it possible to have an employee with more than one department, right? By putting more values over here for department? The answer is no, right? We cannot. Why? Because it's in first normal form for department number, which is the foreign key in the in the employee relation. We cannot have more than one value. And DNR, if you declare that as not null, then yeah, it must have at least one value, at least one and maximum one to one, right? So that cardinality is satisfied, right? So let me mark it over here. Yeah, these two are satisfied by our implementation. Now we need to see 1 to n. Can a department have, is it possible for a department to have zero employee, right? That's what we have to see. So here we go. There are four departments, right? Marketing, call center. For marketing, we have two employees, John Smith and Paul Barker. For call center, we have Emma Lucas. But for 3 and 4, we don't have any, right? Those departments are not present in the DNR. So the conclusion is that, this part is not satisfied, right? Out of the four cardinalities, these two are satisfied over here, right? But we check that this minimum part is not satisfied, right? We have this, we have the instances of finance and ICT department for which we don't have any employee. All right, so it is possible, right? So yeah, this cannot be enforced by our relational model as we have over here. Okay, now the final thing that we need to discuss is that can a department have, okay, minimum one, an employee can have, okay, an employee, department should have at least one employee. That is not, okay, sorry about that again, I should have used this one, not that one. Yeah, the department should have at least one employee, so that cannot be enforced. All right, so these things are slightly intense, so I would request you to spend good time making sure that you follow these things. This part is not satisfied. One-to-one is satisfied, right? One-to-one is satisfied because the DNR that you have is not null, and yeah, you cannot have multiple values there, so these two are satisfied. This part is not satisfied, right? What is it? The department having at least one employee. No, in our example, the last two departments, which are finance and ICT, they don't have any employee. Can a department have multiple employees? Yes, we have that, right? The marketing has two employees, right? So I would say 3 out of 4 cardinalities are supported by this mapping, and this mapping is good. We can't have any other mapping possible, right? Good. Let's keep moving. And now we would look at the third kind of cardinality, which is N to M or many to many binary relationship. So M to N relationship type are mapped by introducing a new relation R. This is going to be interesting. In the earlier two relationship types that we saw, which were binary 1 to 1 and binary 1 to N, we did not create any additional relation for relationship. Here, for M to N relationship type, they are mapped by introducing, stars means important, okay? Introducing a new relation R, okay, fine. Now, the primary key of R, which is a new relation that we are creating, is the combination of foreign keys referring to the primary keys of the relations corresponding to the participating entity type. I know there's a lot of we have a lot of information in this bullet, but yeah, the very moment you see the example, everything will fall in place. Okay, but one more time, it's worth going over one more time. Okay, now the new relation that we would need to define for this N to M relationship type, the primary key of R, this new relation, will be the combination of foreign keys referring to the primary keys of the relations corresponding to the participating entity types. Good. Now the attribute types of M to N relationship types can also be added to R. Okay, good. So now we need this example. Let's see. Here again we have the entity type employee, but a new entity type now we are using, which is project. Employee entity type has the same attribute types, SSN, e-name and address. Project has the attribute types PNR, project number, P-name and P-duration. And here the relationship is works on. Now in this scenario, an employee can work on minimum of 0 project to maximum of n project. And a project will have minimum of 0 employee to maximum of m employee. Okay, and this relationship which we are calling as works on has its attribute which is hours. Okay, so if an employee is working on a project, then yeah, we would like to know for how many hours a specific employee is working on a specific project. Okay, so let's see how we are going to map. First thing you'll have to do would be to define a relation for employee entity type here. Okay, it's a simple step because you'll simply put the attribute types in here. So SSN, the primary key, then ename and address. Good. So ename, again, we are considering as atomic here. If it is composite, then you will put two attributes there, right? You'll have first name and last name. For project, that's our second relation. We have the attributes PNR, PName, and P duration. Good. And finally, the most interesting thing is over here. All right. For this M to N relationship type, we will have to create another relation like works on. And in works on relation, we'll have to put two foreign keys SSN, right? That will refer to the primary key SSN of employee, and PNR, that's again a foreign key which will refer to the primary key PNR of project. Fine. And then this attribute hours, we will put that in the works on. And since our primary key is the combination of the primary key of works on is the combination of SSN and PNR, right? That is our primary key. None of these attributes could be null. Entity integrity constraint, right? So SSN or PNR cannot be null in works on. All right, good. That's a straightforward, much simpler mapping compared to the ones that we have seen earlier. We will dive deeper into this with the help of some tuples. So here we have the tuples for employee. 3 employees, John Smith, Paul Barker, Emma Lucas. And the project, right, there are 4 projects, 1001, 1002, 3, and 4. Good. And then here is the relationship. The relation that corresponds to the relationship. We should be very careful about it. Relation means, well, very soon I'll say that relation means a table, but not now. Okay, but relation you can consider as the most basic object of a relational data model, right? I should be careful about these terms, but yeah, take it as a definition for the time being. Okay, so in works on, we have the social security number of the employee followed by the project number and hours. So 511 means John Smith, 1001 is B2B. So John Smith is working on B2B for 10 hours. 289 is Paul Barker. Paul Barker is working in B2B for 80 hours. And yeah, this is again the Paul Barker only is working on 1003, which is websites for 50 hours, right? Good. So what was the cardinality? Okay, 0 to M, 0 to N. So here we have 289, right? 289 is what? 289 is Paul Barker. Paul Barker is working on multiple projects, right? So that is satisfied. An employee can work on more than one project. And a project like 1001, right, has 2 employees, right? 511, which is John Smith, and 289, which is Paul Barker, right? So this many to many kind of thing. This, wait a second. These things are satisfied. One employee is working on multiple projects and a project has multiple employees. That is established by this mapping. Now, can we have a case where an employee is working on no project, right? So for that, 356 is not present here. Then yeah, yes. You know what? An employee can work in 0 project. So that cardinality is also satisfied. How about the case like can a project have a 0 employee? So for that we'll have to look at the project column over here, PNR column here. 1001, 1, 1 and 13. So 2 is missing and 4 is missing, right? So yeah, all the cardinalities are being satisfied by this mapping. Very interesting case. All right, so let's move on to the other class, which is of unary relationship types. We have seen binary, so all these cases, all the cases that have been discussed were binary. Okay, one to one to many, and many to many we have seen. Now we will go to the unary relationship types. Okay, there we'll have only one entity type, so it is also called a recursive. Here we have uh, two possibilities we are discussing here, which is a recursive one-to-one and one-to-n relationship type. It can be implemented by adding a foreign key referring to the primary key of the same relation. This is recursive, right? Therefore, we don't need any other relation, just one relationship is enough. Now, for recursive relationship, which is unary, right? Unary is recursive. Unary means you have only one relation for this relationship. The first bullet is discussing one-to-one and one-to-n. Now, in case of one-to-one and one-to-n relationship types, which are recursive, we can implement those similar to the way we have done earlier by putting the foreign key, okay, referring to the primary key in the same relation, right? So this is simpler. One-to-one, one-to-many recursive relationship can be implemented by using a foreign key in the same table. All right, this is unary recursive, so you don't need another table or another relation. Just this relation is enough, and that foreign key that you have would be referring to the primary key of the relation. Got? Great. Now let's move on to slightly more complex case, which is end-to-end recursive relationship. Okay, for an end-to-end recursive relationship type, a new relation R needs to be created with two not null foreign keys, right, referring to the original relation. So this again is very similar to the M2N relationship that we saw in the binary case. Just we saw that. There also we were required to uh, define a new relation, and that new relation we would need two foreign keys. Same thing we are doing here also. We would need a new relation R, and it needs to be created with two not null foreign keys referring to the original relation, right? So we need example badly for these cases. All right, so we would first start with the unary relationship of one-to-one type, right? One-to-one. Look at the maximum cardinality type. This is called uh, supervise, right? Supervisors kind of relationship. All right, but the requirement is that here an employee is supervising only one other employee. Okay, who supervises whom? So employee, the relation that we have here has the social security number SSN, which is the primary key. E-name is the name of the employee. Address is the address of the employee. Okay, and then we have the supervisor here. Now looking at the relationship, right, we don't have anything like existence dependency. Therefore, supervisor, which is the foreign key over here, can be null. All right, so yeah, it's not we don't need to enforce the not null constraint here, because yeah, we can have some employee, as the ER diagram is saying, that uh, the employee can have zero supervisor, or it can have maximum one supervisor, and the supervisor will be supervising zero employee or maximum one employee. That's an interesting case. All right, don't try to map it to the real life scenario that it doesn't happen. We are thinking about this possibility. Okay, good. So let's see. We are now looking at some tuples corresponding to this mapping: SSN, e-name, address, and supervisor. We have John Smith, who's supervising 289. Who's 289? 289 is Paul Barker. But you know what? John Smith is also supervising another person who's Emma Lucas, right? But if you go back to the ER diagram here, it says that a supervisor should supervise maximum of one, but that is being violated over here, right? So this is a violation. There's one violation of the constraint. Okay. Fine. Then, yeah, Paul Barker is being supervised by 412. Who's 412? Is Dan Kelly. Good, that's fine. And Dan Kelly is being supervised by no one. That is also allowed, right? So we say that an employee can have zero supervisor, right? So that is being evident in the case of Dan Kelly. Dan Kelly has no supervisors, right? And an employee can, okay, wait a second. Good. So let's see. Fine, we have seen some cases. Paul Barker is being supervised by 412. That's Dan Kelly. Dan Kelly is not supervised by anyone. Emma Lucas is being supervised by 289, who is Paul Barker. But Emma Lucas 356 is not supervising anybody, right? So that case is also being satisfied, which says that an employee supervises zero employee, right? So that's fine. But uh, an employee supervising more than one other employees is being not supervised, is being not supported, right? But this mapping is good. Okay, what we will do now, let's move on to the other cardinality, which is recursive again, but this is going to be m to n, right? Yeah, why? Because look at the, wait a second, this was 1 to 1 and now you're looking at n to m. Here in this case, what can happen is that one employee can be supervised by multiple supervisor, and one supervisor can supervise multiple employees. If we have that kind of scenario, then we would need another relation like supervision. And for supervision, we will have the foreign keys of the supervisor as well as the supervisee. Supervisee is a person who's being supervised, and supervisor is the boss who's supervising the supervisee. Good. So for employee, simple social security number, employee name and address. For supervision, we will need two foreign keys. Supervisor is referring to SSN. Supervisee is also referring to SSN, right? So simple enough. Good. Now we will look at the, and here the cardinalities are 0 to n, 0 to m, or n to m. Fine. So we will look at some tuples just to make sure that we've understood this case or this concept. We have the employees John Smith, Paul Barker, Emma Lucas, Dan Kelly. So here we have the pair of the supervisor and supervisee. 289 is supervising 511. 289 is Paul Barker is supervising John Smith. Good. Then Paul Barker is also supervising 356, right? So that is fine. We have a supervisor supervising many employees, so that is satisfied. Okay, and then 412 is what? 412 is Dan Kelly. Dan Kelly is supervising 289. 289 is Paul Barker. Good. 412 is supervising 511, which is John Smith. That's good. And interestingly, 511, which is John Smith, is being supervised by these two people. Who are these? These are 412, that's Dan Kelly, as well as 289, which is Paul Barker, right? So fine. This part is also being satisfied, that an employee is being supervised by multiple supervisors, right? They're supervised by multiple supervisors. And then we have people like Emma Lucas, 356. Well, 356 is not present here. Means that Emma Lucas is not supervised by anyone, right? So that is also possible here. No, wait a second. 356 is here. Here you go. 356 is Emma Lucas. She is supervisee. She is being supervised by 289. Who's 289? 289 is Paul Barker. So in fact, Paul Barker is supervising 511 as well as 356. And yeah, 412 is Dan Kelly. Dan Kelly is supervising 289, who is Paul Barker, and 511 is John Smith, right? So in fact, it is satisfying all the four cardinalities. What we will do next, now we will move on to the we have seen binary relationships. We started with binary, then we moved on to unary, where you saw the recursive relationships. Now we are going to the higher order n-ary, and there will have in fact ternary relationship types involving three entity types. So to map an n-ary relationship type, we first create relations for each participating entity type. Good. And then we then also define one additional relation R to represent the n-ary relationship type, and add the foreign keys referring to the primary keys of each of the relations corresponding to the participating entity type. It's very simple, right? There's a lot of text for each bullet, which may uh, keep you more confused, but yeah, it's simple enough. Wait for the example. Now the primary key of R is a combination of all foreign keys, and which are all not null. Okay, and any attribute type of n relationship can be added to this new relation R. So here we go, right? I was waiting for this example. This is n-ary, which you can probably call ternary, right? But we call that, after binary, we call that n-ary. Okay. So here in our example, there are three entity types involved: tourist entity type, hotel entity type, and travel agency entity type. And tourist entity type has the primary key TNR. Hotel entity type has the primary key HNR. Travel agency has the primary key ANR. And the relationship that we have here is booking. And the booking has a price. And look at the cardinalities. It is 0 to n, 0 to n, and 0 to n. Good. So how do we implement this? We will have to create one relation for each of these three entities. So the first relation is for tourist. You will put the TNR as the primary key, and the remaining attributes for the tourist, like tourist name, tourist age, tourist address, and all that. For travel agency also, you will have the ANR. You'll create a relation for travel agency, call it travel agency, and you'll put the primary key ANR and the remaining attributes. For hotel, you'll have the primary key HNR, and you'll add the other attributes. And the most important relation here is the booking relation. All right. And in the booking relation, now you will put all these three primary keys as the foreign keys. So there are three foreign keys: FK1, FK2, FK3. And these three foreign keys are coming from the primary keys of the participating entity types, right? For which we have these relations: tourist relation, travel agency relation, and the hotel relation. Okay, and this price attribute that we have for the relationship booking will find the place in the booking relation. Good, simple enough. And yes, since our primary key has these three attributes, which are TNR, ANR, and HNR, they are all not null. Similar to the previous example, we can think of this relationship also, which is about offers, right? And here the entity types involved are instructor entity type, semester entity type, course entity type. Okay, instructor has the primary key INR, which is instructor number. Semester entity type has the primary key, which is SEM year, and course entity type has the primary key, which is CNR. Okay, and here the cardinalities are 1 to n, 0 to n, 0 to n. How do we map? We'll have to define these relations: instructor relation for instructor entity type with INR as the primary key. Then we'll have a course relation for course entity type, CNR being the primary key. Then we have the semester relation for the semester entity type, primary key being SEM year, and the remaining attributes. And offers is the most interesting relation here, because that will implement this n-ary relationship, and it will have the foreign keys INR, CNR, SEM year. Okay, and they all need to be not null, and they all taken together will form the primary key, similar to the previous example. Here you're looking at an example. Okay, example with the tuples. Instructors, you can see we have three instructors. These are, I think, the authors of our textbook, Bart, Wilfred, and Sepe, with their number 10, 12, and 14. Then there are these courses, database management, analytics, and Java programming, right, with the course numbers. Then we have some semesters. Okay. Then in the offers, you can see we have the combination of the instructor, then the course number, and the semester, right? Similarly, that. Okay. Good. So what is remaining now are a few other issues beyond the relationship, right? We have seen all the relationships mapping. We saw the entity mapping. Now let's look at the attribute types mapping, because attributes can also be tricky at times. So for a multi-valued attribute type, right, what do we need to do? Because for an attribute type which is multi-valued like phone number, you are not allowed to have multiple phone numbers in a single cell, right? So the solution here is that we'll have to create a new relation R for multi-valued attribute. Okay. Now what we do next after creating this new relation R for these multi-valued attribute type, we put the multi-valued attribute type in R together with a foreign key referring to the primary key of the original relation. This is very interesting. Okay, we have an example, and using the example I will explain. Now the multi-valued composite attribute type are again decomposed into their components. If your multi-valued attribute is composite, then you will have to break it down. So it's slightly more complex. The primary key now is set upon the assumptions. Let's look at this example, right? So here the employee entity type has social security number, e-name, address, and phone number. Now, if this e-name is composite, right, then you can break it down to first name and last name. That's what we had in the previous slide. But for phone number, this is interesting because, it simply means that it is multi-valued. An employee can have more than one phone, right? And sometimes it is possible that multiple employees may be sharing a phone number as well. Okay, so how do we map it? For employee, you will have employee relation with SSN, employee name, and address. And you will have to create a new relation here, amp phone. And in amp phone, you will put the phone number along with the social security number of the employee who owns the phone number, right? So in this new relation that you have, the social security number is now your foreign key. And this foreign key is getting the value from the primary key of the employee or relation. Okay, let's look at some examples here. With the same employees, we have John Smith, Paul Barker, and Emma Lucas. There's SSN. John Smith is 511, 289 is Paul Barker, 356 is Emma Lucas. They have their address and then the department number. Department number is not very important in this case. Important is this relation here, which is EMP phone. EMP phone will have the employee and the corresponding phone number, right? So phone number first and then SSN. You can reverse the order as well. That would remain the same thing. So let's look at the first two phone numbers. 900-244-8000. 900-244-8000. So this phone number is shared by two employees, right? It is possible they may be residing in a dormitory, right? And yeah, a dorm or any house where they have a landline phone number, right, which is being shared by two employees. Good. So just the phone number cannot be used as a primary key because you can have duplicates, right? Therefore, the primary key should be a combination of phone number as well as SSN. Okay, great. Then see, just SSN is also not enough because 289 Paul Barker has two phones, right? This landline connection, as I came up as an example, and probably the cell phone number, which is 900-244-8002. Okay, so yeah, that's an interesting case. What we do for multi-valued attribute type, you will have to create a new relation for that attribute which is multi-valued along with a foreign key, and foreign key should be mapped to the primary key of the original relation. Right? That's what we have in this example. Important. Fine. Now let's also look at the mapping of weak entity types. Right? How do we map weak entity type? That is also very common. A weak entity type should be mapped into a relation R with all its corresponding attribute types. Fine. And then a foreign key must be added referring to the primary key of the relation corresponding to the owner entity type. Right? So when we learned about weak entity, we also learned about the owner entity type. So what we do here, in order to map a weak entity type, you'll have to create a relation R for the weak entity type with all its attributes, and then you have to put a foreign key, and that foreign key will be mapped to the primary key of the owner entity for this weak entity type. Now because the weak entity is existence dependent, this is important, okay? Because of the existence dependency of the weak entity type, the foreign key is declared as not null, right? Very important here. Now the primary key of the weak entity R is then the combination of the partial key, which means the key that the weak entity had, which is not the primary key, but yeah, along with the foreign key. Okay, so I will explain that in the example, like what is the partial key there. Good. So we saw this example, right, in our discussion when I introduced you to the concept of weak entity. So here we have two entity types, room and hotel. Room is the weak entity type. Weak entity type is room. And a weak entity type is represented by double rectangle. So hotel is the owner entity type. Hotel is the owner entity type. Okay, and hotel has the primary key, which is HNR, hotel number, and hotel has H name, which is hotel name. And let's look at these cardinalities. A room will belong to one and only one hotel, so in a way this is what existence dependent, right? Now this HNR that you have here is the foreign key. You can see it is what, slanted or italicized, so this is foreign key. Now this foreign key HNR along with RNR, which is room number, together will make what, the primary key. And here this room number that you have RNR is called the partial key. RNR is the partial key. Okay, so this partial key with this foreign key HNR together will form the primary key of the room relation. Okay, so how do we map this weak entity? The hotel, which is this the owner entity, would be mapped to a relation hotel with its own attributes HNR and H name. HNR is the primary key of hotel. H name is the hotel name of hotel relation or the hotel entity type. Then you need to create a relation hotel for the weak entity type. You need to create a relation room for the weak entity type room with its primary attributes, which are room number, RNR, and the beds. And you will also have to borrow a foreign key here. What is the foreign key here? The HNR, which is coming from hotel. And what is hotel? Hotel is the owner entity type, right? Now this combination of RNR along with HNR. RNR is room number along with HNR, which is the hotel number, together will form the primary key. Good. And here you're looking at the some tuples. So for room, we have room number 2 in the hotel 101. 101 is Holiday Inn in Chicago. Then you have room number 6 in the same hotel, Holiday Inn in Chicago, and you have room number 8 in 102, which is Holiday Inn in San Francisco, right? And the number of beds you have over here. And yeah, the hotel is simple. Hotel relation will have hotel number as the primary key, right? These are all unique. Now what we do finally, we'll put everything together like what all we discussed in this chapter. which was broken into 3 video lectures, part 1, part 2, and part 3. Relational data model part 1, relational data model part 2, relational data model part 3. Okay, so we have a kind of mapping, ER model to relational model. Entity type of relational model is mapped to relation, that corresponds to relation in relation model. For weak entity type mapping, we use the foreign key, right? For one-to-one and one-to-n relationship type, we use the concept of foreign key in its mapping. For M to N relationship type, we use a new relation with 2 foreign keys. For n-ary relationship type, we create a new relation with n foreign keys. Simple attribute types are mapped to attribute types. Composite attribute types are broken down into the component attribute types. Multi-valued attribute types, for that we need a relation and a foreign key from the main relation or main entity type. And key attribute types, they are mapped to primary or alternative key. All right, and now we will put everything together, all the examples that we saw. So for the employee entity type, now we have employee relation with social security number SSN as the primary key. Then we have e-name, street address. Here e-name and street address is assumed to be atomic. If it is not, then we'll have to break that down into its components, and we'll have those many attributes here. You have city, then the sex of the employee, date of birth of the employee. MNR is the foreign key for the manager who's managing an employee. DNR is again a foreign key. DNR corresponds to the foreign key for the department in which this employee is working. Okay, so that has been explained here. MNR is the foreign key, refers to SSN in employee. Null is allowed, right? Because an employee may not have any manager. In that case, we will keep that as null. DNR is a foreign key that refers to the DNR of the department, not null, because an employee must belong to a department. In department, we have DNR as the primary key, then DName, name of the department, D location, and MGNR is for manager SSN. MGNR is a foreign key that refers to SSN in employee and not null. Right? This should not be a null, because every department should have at least one, one and only one manager. Right? That was required in our conceptual model in the ER diagram. For project, we have PNR as the primary key, P name, P duration, and DNR. DNR means the department to which the project belongs, to which the project has been assigned. Now, DNR is a foreign key, refers to DNR in department, and it is not null. Okay, so the project must be assigned to a department, right? So it is not null. Works on is a relationship with social security number, SSN and PNR, and hours. SSN is a foreign key which refers to the SSN in employee, it's not null. PNR is foreign key, refers to PNR in project, it's not null. All right, so that was it. Let me stop right here. I will see you in the next class, or sorry, the next video lecture is what I mean. Bye bye, take care.